So this is for me a good summary. So the purpose of this is not to say that LPWAN technologies are bad. They are at no point bad. They are very good technologies for their applications. So that means that if you have low data rates, so there's a low amount of data coming, you basically want to transfer a bit, like an on or off state of something. Maybe then they're good. If you want to go up with data rate, so that means you want to go to the right at this figure, you need to consider other technologies because the LPWAN technologies will soon have a limitation. Also at the left, you see 3 different parameters. You see the node density and the update rates. So that means that if you have a high density of nodes and you have high update rates, the LPWAN technologies like LoRaWAN and Sigfox will not do the trick for you. You need other technologies. Also, if you want to consider low power devices, which means that you want to be battery operated with a small battery and should last for a very long time, you also need to go up to get the low battery. On the right, you will see that BLE is obviously a very good solution for the very short range. So that means if you are considering covering a room of 5 × 5 meters, that you want to do some sensors in that room only, I would obviously say that BLE is a very good solution because it's very power efficient. You get high data rates, update rates, and very low power consumption. In case you want to do a factory, like 10,000 square meter factory, and do quite much data from those to do to monitor your factory, to do in order to do the right business decisions for your factory, then I think you're in the green area. And if you're covering a large city and you want to monitor like position of garbage bins, which you want to update every 1 hour just to know where they are, I think obviously you will have to go with some of the LPWAN technologies like LoRaWAN or Sigfox. So all of these technologies have their benefits, but you have to adapt your solution to the requirements in your application. So to summarize, due to congestions, due to battery lifetime, and due to regulations, LPWAN technologies are suitable for update rates of 50 minutes and above. That's basically what the studies show and what the regulations show. If you have very high density network, like 100 nodes connecting to one gateway, you probably want to go up to update rates above or up to 1 hour or above if you want to have a reliable network. If you have if you need a wireless sensor network with many nodes and high update rates, RIIoT is obviously a much better solution. And then you end up with different application this is suited for. So again, LPWAN, if you want to do water metering, for instance, 169 MHz wireless M-Bus, very much used for water metering, which you do 5 to 15 readings per day and covering a very large area. Obviously, LPWAN is the solution, way to go. If you do soil moisture sensors with reading the soil moisture every hour, that's also LPWAN. The challenge there is if you want to control like irrigation systems at the same time, you need two-way communication. So that means some of the LPWAN technologies will actually not do the trick, as they really do not support two-way communication. City air pollution, monitoring every 1 hour or something, which also would be a very good solution application for LPWAN. If you just want to send data when something has happened, like an alarm, or just that now this door has been opened, or no, which is also very rare events, but you want to send just on the events, you can also do it with LPWANs. However, if you have, you might not get acknowledged because they don't support two-way. So with RIIoT, you have other type of applications which suits better. That means facility management of a property. You have service monitoring, building management, parking occupancy sensors, machine learning or AI, where you want to do, you need more data in order to do to do back-end artificial intelligence, for instance, for predictive maintenance. Also, if you want to have control systems where you need an active downlink to control something, you would like to use RIIoT.